In this chapter, we'll be talking about two important sequences. One is called arithmetic sequence, which we call AS, and the other one is called geometric sequence, which we call GS. So let's begin with the word called sequence first. Sequence itself it means that it's a list of numbers arranged in order. So please pay attention to the word called in order. We have an order with the numbers, the first one, the second one, and the third one. And then in this sequence, each number we have another term for it, which is called term. So what does that mean? For example, in part A, it's very obvious for you to see that it's consecutive odd integers, positive integers, 1, 3, 5, 7, 9. And so I just list out four numbers over there. And then so first of all, for this one, we will call it the first term because it's in the first position. So you remember that we have an order when we write the number. And then for the second one, we call it the second term. This one is the third term, and 7 is the fourth term, so and so. A sequence is not necessary to be ascending or descending. It can be like in part B, the numbers is alternating. You see the numbers are changing in the signs from positive to negative, negative to positive, and onward. So it's alternating in the sign. We may have a sequence like multiply of 3. So let's see if you remember the word called multiply of 3. And then at last, the weird thing is sequence in a sequence is not necessary to be, you can see a pattern over there. For example, D, you see that it seems like the numbers are very, they are unrelated to each other. You can't guess what are the numbers after the 6, for example. So that's why I would like to emphasize that in a sequence, the number may not to be having a pattern. So this is the main point. And then so before we come to some technical terms, so you can also see some sequence carry a special name like the Fibonacci sequence. So it is an Italian word, Fibonacci. And then so it is, the numbers include, first of all, you should have 2, 1 in the beginning. And afterward, you add up the previous two numbers to get the next one. That means 1 plus 1, I have 2. Next one would be 1 plus 2, so you get 3. Next one, you get 2 plus 3, you get 5. Afterward, you have 3 plus 5, you get 8, for example. Then let's see whether you can write down the next 3 numbers, and afterward, you can check it in the internet. After you have a general idea about sequence, then we come to some technical terms we need to know. So let's pick an example like if you have a sequence called 4, 7, 10, 13 plus dot dot dot. And then so we have some terms. For example, this one is called term 1, and then you can use English, of course. But we can also use a label called T1 to represent it. 7, we can use T2, term 2 is like T3, and then T4, etc. If I'm going to ask you, can you find out what is T100? This may not be very easy, or you have some tricks to find it out. But the main point is, if you can find a function which can represent this sequence, and then we call Tn, then we can simply put n to be 100 to get the numbers I'm asking you right now. So this function, Tn, we have another name, which is called, it is the general term of the sequence. Or you can talk about this is the nth term of the sequence as well, because you are talking about the nth position. So that's why it is one of the major concern to see how we can find the Tn for various sequence, especially when we are talking about arithmetic sequence and geometric sequence afterward. And then besides T1, T2, T3, so you can also see in some books they would like to use different symbols, like they may call it like A1, A2, A3, A4, A5 as well. Or sometimes the brackets is missing, so we call T1, T2, T3, T4, etc. But indeed, they are still talking about the positions of the sequence, and you want to find it particularly. Next, we come to take a look in the general term of 5 particular standard sequences I would like you to look at. So first of all, in part A, you have very obvious consecutive positive integers, 1, 2, 3, 4, 5. So in order to obtain the number, you find that T1, T1 is 1, T2 is 2, T3 is 3, T4 is 4, etc. Can you guess what is Tn? The nth term, what is it? Yes, quite obvious. T1 is 1, T2 is 2, T3 is 3. You may make a guess that Tn will be an n. It's pretty easy, right? And then next, according to this general term of consecutive positive integers, so we can deduce the rest of the following. Okay, right now you know 1, 2, 3, 4, dot, dot, dot. So the general term is Tn is n. So what if we now change to talk about the consecutive positive consecutive even integers? So how will we get the Tn from the other one? Now you can take a look is 1 times 2 is 2, 2 times 2 is 4, 3 times 6 is 6, 4 times 2 is 8, right? Can you see that in order to proceed to the blue sequence in part B, you're just talking about times 2 to each of the term in the sequence. So that's why for the general term it's also times 2, which gives you 2 times n, that means it's 2n. Now it comes to your general term of the sequence of consecutive positive even integers. Similarly, now we came to take a look in C. They are consecutive positive odd numbers. Now you will see that this time is 2 minus 1, 4 minus 1, 6 minus 1, and 8 minus 1. Can you see that it's every time you minus 1, you get the sequence in the terms in the sequence in part C. So that's why Tn for the odd integers, they are 2n minus 1. So please check whether it's okay to you. If no, then we come to D. D, can you see that the numbers, they are 1 square, 2 square, 3 square, 4 square, and 5 square. They are the square numbers. So that's why the sequence will be n squared. Is it alright to you? If so, can you take like half a minute to look at E? After square, make a guess what I'm going to ask you. That's good. You find it is 1 cube, 2 cube, 3 cube, 4 cube, 4 cube, and also 5 cube. So that's why what should be the general term of this particular sequence? Yes, that's good. Is n cube afterward. Next, we come to some examples talking about question sequence. Let's start with number 4. Number 4 is given to you that you have a general term of such a sequence called Tn is kn plus 8. And then please make sure that there are there are 2 letters. One is, it's talking about k is a constant. K is a constant. Or sometimes you can say that it's an unknown that you're going to find. Can you see it's asking in part A. And then while in the value of n, you can say that it's a variable. That means you're talking about T1, T2, T3. T1, this is the first number, you can calculate it. T2, you can put n to be 2, you get another number. T3, you can put n is 3 to get the third number, etc. So now in question, it tells you T6 is 50. So that's how you can find the value of k quite quickly. As T6 is 50, T6 itself can be, you can do the substitution in the function, in the general term here, and which is talking about k times 6 plus 8 equal to 50. So 42 on the right, you have 6k on the left. That's why k is a 7. So it's quite easy if the question tells you that the value of the function, like you have T6 is 50 here, and then you can get to k quite easily. Besides, what's the meaning of T6 is 50? It carries another meaning like first number, second number, third, fourth, fifth, we don't know, but I know that the sixth one is 50. And then this is another meaning behind T6 is 50 as well. Coming up next week, we want to find the 10th term. That means you're going to find T10. And now it will be very easy as well, because now you get k is a 7, and you substitute with 10 and plus 8. So that's why you get 78 quite quickly. And finally, it would be one of the questions I find many students could understand quite well. It would be find the value of m such that Tm is 92. So what does that mean? That means it's like you have some numbers right in this way. Okay, 1, 2, 3, 4, 5, 6. 6 is 50, I know already. 7, 8, 9. The 10th number is 78. I've got already in part B. So dot 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 dot, etc. And now I want to know in which position. So that means the nth number, nth term. So where the value is 92. So this is the meaning behind part C. But in calculation is nothing special. And Tm is 92. What does that mean is K is always constant, so which is a 7. And your substitute will be M plus 8 to be 92. So that's why you just merely are talking about a substitution problem, putting N to be a M, and then in the formula. So afterward, then you simplify the question quite quickly, which is 7M will be, what's that, 84, M is a 12, so that's all. And then so bear in mind that the meaning behind M is 12 is, that means the 12th term in the sequence, which is 92 over there. So make sure that you know this concept because we are going to see a question related to this concept very soon. Next, we come to example 6, which again, the general term of a sequence given to you will be Tn is n squared plus 18n plus 32. It's in quadratic, but somehow we don't know how will it be useful in talking about the sequence. Another question is quite funny because it's talk about, does it contain the term 0? Oh no, what does that mean? Indeed, it's talking about, well, if you write the numbers one by one in a sequence, can you get 0? That means, for example, if you really want to check it out one by one, then you can do it in this way. T1, first term, is 1 squared plus 18 plus 32, which is 19, 32, 51, right? T2 is 2 squared plus 18 times 2 plus 32, which is 36 plus 4, 40, 72. But then you can go ahead to get T3, T4, etc. That means that the numbers in the sequence are 51, 72, and then T3, you can calculate it, T4, so and so. And now I'm asking you whether does it contain 0 or not. If you're smart enough, you will see that, oh, that's good, because the numbers are increasing. Can you see that? So that's why it's probably can't contain any term 0 over there. But in math or in a more systematical way, can you find a method to find it? The key would be, if you want to find T1, then you put n is 1 over there. If you want to find term 2, then that means you find the 2 there. If you want to find term 3, you put n to be 3, so and so. How does this method helps you to solve the problem, to explain your answer? And you can simply say, if it's possible, that means I should find out a possible n, which refers to the position, so that the value is 0. If you can solve it and find a number, then you can say there's a term 0. So as a result, now it goes to n squared 18n plus 32 equals 0. Can you find out why we at first I said it's about quadratic? Because the question in this is about solving quadratic equation, though it doesn't mention anything about it. Okay, now you can use a calculator to get the value of it, which is n to be minus 16 or minus 2. Well, we can solve the problem, right? We can find the value of n. But does it make sense? Does it really mean that it contains the term 0? If you can understand the idea about the value of n in sequence, then you can solve it. Because n itself is not just talking about a variable or you're doing substitution, but it's talking about the position of the term in the sequence. So what does that mean if you have a 0? That means you can say, yes, that's good. That means if you have the term called the minus 60th term, you have the term called 0. Similarly, if you can write down the minus second term, you have the term called 0 as well. But does it make sense? No, definitely. Because when you're talking about term, you're talking about the first, the second, the third, the fourth, etc. You can't have negative 60th and or nor negative second. So that's why both of the answers are meaningless in sequence. So that's why, or invalid in sequence. So that's why we reject both of the answers and we say, no, it does not. So this is the answer of the question in example 6.